Here we go. We have a question, minimum number of deletion and insertion. So you have given two strings s1 and s2. Our task is to remove or insert the minimum number of characters from or in string 1 so as to transform it into string 2. It could be possible that the same character needs to be removed or deleted from one point of string 1 and inserted to some another point. Suppose we have this example, string 1 is HEAP and string 2 is PEA. If you remove this H, so we have done one deletion, and after doing an deletion we insert P here, so we have done two operations. So now string is PEAP. After that we will remove the last P, so it will become PEA. So in total we have done three operations. So that's about this problem. Let's build the approach. So we have this string. We can either delete a character from string 1 or insert a character in string 1. So we have to be optimal here, and we need to find the minimum number of operations. So that's where DP comes in. We have a string NEAP, and we have another string PEA. So first we have this cell. This means our string 1 is empty and our string 2 is also empty. So our string is equal. We don't need to do any operation. The answer is 0. We have this means our string 1 is empty and our string 2 has one character. So we need to remove this character. So the total number of operations is 1. Our string 1 is empty and our string 2 has two characters, so we need to do two operations. Here we have to do three operations. Here we have string 1 only n and our string 2 is empty, so in this cell we need to do one deletion. So one operation we need to do. Here we have a character here and a character here, so this character does not match. So either we can remove this character. Remove this character means if I remove this character, our left out string is this from string 1 and our string 2 remains same, so we have this cell. So that's about the deletion. If we want to insert this character, so this character and this P here, if I insert the P, so the character is matching. So we need to find the left out string from string 2. So either we uh, get a get a character from here, or we can get a value from here, and we need to find the minimum number of operations. So we take the minimum from these two cells. In this, the minimum is 1, but we have n and p. So if we remove this and insert this, so we need to do two operations. So first we take the minimum from this cell or this cell. If character is not equal, then we add 1 here. So the answer is 2. 1 for deletion and 1 for insertion. If our string 1 has only n and our string 2 has PE, and we are matching the last character. In this, the character is not equal. So here, this cell, the character is not equal. So either we get value from here or we get value from here. And we need to take the minimum value. The minimum is 2, but we also need to add 1 because the character is not equal. So if I remove this and insert PE, the total number of operations is 3, so that's why 3 is the answer for this cell. What about this? N and A is also not equal, so we take the minimum value from here and here. The minimum is 4, we need to add 1, answer is 4. What about this? We have N and P here and string 2 is empty. So here we need to remove N and P. So the total number of operations is 2. 1 for deletion, this cell, and remaining cell we have this. So remaining value we get from this cell. So the answer is 2 in this case. What about this and this? The character is not equal. We take minimum from here and here. Minimum is 2. The answer is 3. In this case, N and P, E and E is equal. So we have NE and PE, means this and this is equal. So the remaining substrings are N and P, which is this cell. So if the character is equal, we need to get value from here. And we don't need to add +1, we just get the value from here. Next we have this and this. The character is not equal, we get the minimum value from this cell and this cell and add +1. This cell is not equal, so we need to add +1 to the upper cell. A and P is not equal, so we get minimum from here and here. It is 3, we add +1. This and this value and this value is not equal, so we get minimum from here and here. It is 2, answer is 3. This value and this value is equal, so we get value from here, which is the remaining substring, which means this substring and this substring. So the value is 2 in this case. What about this? We have 4 characters in string 1 and 0 character in string 2. So we have to delete all 4 characters. The answer is 4, which is we add 1 to the upper cell. Next, P and P is equal. We get value from here. The answer is 3. E and P is not equal. We get value. We get value from these two, and we need to find the minimum. It is 3. We add +1. P and A is not equal, so we get value from here and here. The answer, the minimum is 2. We will add +1. So answer is 3. So the answer is 3 in this case. We have 3 answers. So let's code this. First we need to find N and M. Then we need to build a DP N+1 and M+1. Then for the zeroth row on 0 cell, means string 1 is empty and string 2 is empty, means it is equal. We don't need to put value here, we just traverse from 1. The row number is 0, so our column number changes. First, for 0 1 cell, we need to add 1 to the previous column. Next we need to iterate from row 1, because we have filled value for row 0. For row 1 it is 1 0, means our string 1 contains 1 character, so we need to delete this character, so we add 1 to the upper row. Next we have a for loop starting from 1. If the character is equal, as you can see we are starting from 1 and 1, so it will probably give you a index out of bound, so we need to take I-1, because we are because string is 0 based indexing. To get this character we need to find I-1 and J-1 for the 0 0 character. If the character is equal, we just need to get to the top left side. If the character is not equal, we need to add 1 plus find the minimum from either the upper row or the previous column. After finding this, we need to just return the last cell. Let's submit this, and after that we will optimize the space complexity. In this, the space complexity is n cross m and the time complexity is n cross m also. One thing to observe here is we are finding I-1, which is upper row. I means current row, I-1 means upper row, I-1 means upper row. This is the same row, means current row. So we need, so we can space optimize this by taking previous row and current row. So let's optimize this. We have this N and M. we have previous row and current row. So previous, this is the 0th row, so I am filling the value, I am taking the 0th row as a previous row first. So this is my previous row, then I'm starting the value from 1. For the 0th cell, we need to take the value, we need to add 1 and add 1 to the previous row. After this we need to traverse. Then if the character is equal, we just need to get the value from previous row left hand side column. If the character is not equal, so we need to find value from previous row or left column, means current row left column. After finding this row, this current row, we just stored our value. This row becomes the previous row, so our previous row changes to the current row and our current row will be the next row. After this we need to get value from previous, because current is initialized, so previous stores the last row. Let's submit this. And here the space complexity is order of m. So the code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. And thank you all for watching.